class. In this class or in this video, I'm going to explain deterministic finite automata. What is deterministic finite automata? And how we can represent deterministic finite automata, I'll explain in this video. So what is deterministic? Deterministic, that name itself gives meaning as we can determine the output. We can determine the output. Okay, na? So from any state, you can consider from any state on any input symbol, DFA means short form of deterministic finite automata is DFA. So DFA can produce exactly one output. So that's why we call it as deterministic. Suppose if more than one output is there, we get the confusion which output is appropriate. But here in deterministic finite automata, which produces our automaton or machine we can call. Okay, this machine or this automaton can produce only one output from any state on any input symbol. So that is deterministic finite automata. But how we can represent a deterministic finite automata? So before going to see the representations of deterministic finite automata, we will see what DFA consists or how we can represent DFA machine. Okay, na? So generally DFA can be represented by using 5 tuples. So these are 5 tuples or 5 tuples. Q, sigma, delta, Q naught, F. What is Q? What is capital Q? We know capital Q is finite set of states, because for designing machine we required states. So depending on problem nature, we need to use required number of states for constructing machine. Okay, na? So all those states are represented within a set. That set is called capital Q. So capital Q is finite set of states. Then what is sigma? So in mission generally in between states or on states, some arrows are there as connections. So those arrows can be associated with numbers. So those numbers are called as input symbols between states. So all those input symbols are represented as sigma. So what is sigma now? Finite set of input symbols. So all the input symbols are represented as a set. So that set is represented as sigma. Then delta is transition function. Whatever the arrows you are using between the states is called transitions. Transition means the move. Okay, na? Suppose when you in between two states, suppose Q1 is one state, Q2 is another state. In between those two states, one arrow is there. On that arrow, 0 is the symbol. So 0 means 0 is the input symbol. So from Q0 on input symbol 0, machine moves to Q1. So that is one transition or one move. So like that, if you collect all the moves, then we call it as delta. Delta is transition function, which takes state as one input, symbol as another input. So tuples, which takes pair of items. One item is state, current state, another item is current input symbol, and which produces one output. So that's why we write delta as Q into sigma implies Q. What is Q? Set of states. In this set of states, which takes only one state. Sigma is finite input alphabet. Okay, na? So from this, which takes one input symbol. So from one state on one input symbol, which produces another state. But whatever the state you are taking as input, whatever that is belonging to Q. Whatever the input you are taking for transition, that is belonging to sigma. After that, whatever the output you are getting, that output is belonging to Q also, because Q is containing all the states which we are used in machine construction. Okay. Then next one is Q naught. Q naught is starting state. If starting state is Q1, then Q naught becomes Q1. If starting state is Q2, then Q naught equal to Q2. So Q naught is initial state or starting state. And F, capital F, is set of final states or acceptance states, because DFA or any other machine, NFA or DFA, which contains more than this machine containing more than one final state. But in DFA, we can reach only one final state finally, or any other state. Finally, after reading the last symbol, we may reach only one state. That state may be final state or that state may be non-final state. So based on that reachability, we say that that string is belonging to so-and-so machine, or that machine can recognize a so-and-so string or language or not. We will decide. In designing part, I will explain. Okay. So this is the basic information related to deterministic finite automata or DFA. So DFA is represented by using 5 tuples. Those 5 tuples meaning is this. But how we can draw DFA? So there are two different ways for representing or presenting DFA. One is graph format, another one is tabular format. So graph format means graphical representation is called transition diagram. Graphical representation is called transition diagram. Okay, na? So this is one way of representing a DFA, and another way is just simply drawing table. It is like a graph and matrix. Okay, na? So generally, in any situation, we can construct it as a graph, or we can convert that graph into table. The table is called either adjacency matrix or any other matrix. Some matrix related to graphs. Here also, so machine can be represented by using digraph. So this is digraph because this graph is containing directions. Okay, na? So this digraph is called transition diagram. So this transition diagram is represented with all the states, whatever the states that are required for constructing machine. Okay. So and input symbols, because on transitions we are using input symbols as labels. In this fashion, we can represent DFA. In designing part, you can easily understand how we can design any DFA based on conditions. Okay, na? So what is transition diagram now? So transition diagram is a graph or digraph which containing all the states. So those states are represented by circles. Please observe here. There are two separately designated states. One state is initial state, another one is acceptance state or final state. So the initial state is easily recognized by this arrow. If arrow is there with any state, that state is treated as initial state. So machine should start with initial state now. So initial state is represented by using arrow, and acceptance state is represented by using double circle, and all the remaining intermediate states are represented by using circles. Okay, so initial state, acceptance state, and all the intermediate states. So this particular diagram is designed based on conditions and language nature. We will see in designing part, we can easily understand how we can design DFA, or how we can convert a DFA after designing DFA, how we can construct a transition table. We will see in designing part, we will see. So this is one way of representing DFA, that is transition diagram. So after drawing transition diagram, again we need to represent machine with 5 tuples. What are those 5 tuples? Q. What is Q? Set of finite set of states. How many states are there? 3 states: Q0, Q1, Q2. So Q is containing Q0, Q1, Q2. What is sigma? Input alphabet. What do you mean by input alphabet? Whatever these symbols you are using as labels on arrows. So these labels on arrows are treated as input alphabet. Zeros and ones are there. Then use input alphabet as 0 and 1. What is the initial state? Q0. Q0 is the initial state. So Q0 equal to Q0. What is set of final states? Only one final state is there. Then represent that final state within open and close curly brace. F. Then what about delta? Q, sigma, delta, Q0, F. What is delta? All the transitions. How can we write all the transitions? Delta of Q0 on 0 equal to Q0. This is one transition. Delta of Q0 comma 1 equal to Q1. That is another transition. Like that, you need to write all the transitions. Or it is very easy representing all these transitions as a table format. That is another way of representing deterministic finite automata, that is tabular form. Or we can directly write all the delta transitions here. So delta of Q1 comma 0 equal to Q2, delta of Q1 comma 1 equal to Q1, delta of Q2 comma 0 equal to Q2, delta of Q2 comma 1 equal to Q2. Like that, if you write all the transitions, that become delta. So instead of writing all, if we can also show all these transitions in this single part or single place, that is called as table. That table is called transition table. So that is another way of representing deterministic finite automata. Even non-deterministic finite automata can be also represented by using transition diagram, transition table, or 5 tuples: Q, sigma, delta, Q0, F. Okay. So what is transition table now? This is the conventional tabular representation of a function delta. Okay. Now all the transitions we are representing as table format at one place. So take 3 columns, and the number of rows are depending on number of states in the diagram. Okay, na? So first column, write all the states. Second column to onwards, you write all the symbols. So based on symbols, suppose 0, 1, 2 is there, then add one more column. Suppose ABC or the symbols, then add ABC. Or D is also there, then so based on number of symbols, you need to take those number of extra columns, including states column. Okay, na? So first take states. How many states are there? 3 states: Q0, Q1, Q2. Just I am showing a transition table for this diagram. Okay, na? Q0, Q1, Q2. What is Q0? Initial state. In diagram, in transition table also, we can easily recognize initial state and acceptance state. Initial state is represented by using arrow. Acceptance state is represented by using star, or we can represent that particular acceptance state within circle. Nothing wrong. If you write Q2 within circle, that is treated as acceptance state. Or if you write star above Q2, that is recognized as acceptance state. Then fill this table according to delta. So what is Q naught on 0? What is Q naught on 0? Q naught. Q naught on 1 is Q1. So Q naught on 0 is Q naught. Q naught on 1 is Q1. Like that. Q1 on 0 is Q2. Q1 on 1 is Q1. Q1 on 0 is Q2. Q1 on 1 is Q1. Anyway, Q2 on 0 and Q2 on 1 are Q2, Q2 only. Q2, Q2 only. So this is another way of representing DFA. Okay. So DFA definition is clear. Okay, na? We can represent DFA by using 5 tuples. So these 5 tuples are also called as components of DFA. Components of, sometimes you may get question like explain or write the components of DFA. So you start with these 5 tuples. What is A? How can we represent machine or automata? By using these 5 tuples, we can represent Q, sigma, delta, Q naught, F. Write about these 5 tuples. These are treated as components. In addition to this, some more components are there. These diagram components. What are those diagram components? Diagram components are circle. The circle is used for representing all the states. And circle with arrow. The circle with arrow is used for representing initial state. And double circled representation is used for representing acceptance state. And arrow is used as transition. So like this, you write all the components. So Q, sigma, delta, Q naught, F are 5 important components. And in transition diagram also, some components are there. Circle is one component. Circle with arrow is one component. Double circle is one component. Simply arrow is one component for representing DFA. And in transition table also, some components are there. State with arrow and state with star or double circle. Okay, na? So like this, we can explain the components of DFA. Okay, so this is about deterministic finite automata explanation and representation of DFA. Okay, so this is all about DFA. Thank you for watching my video.